a fantastic day in geometry. I'm so sorry I couldn't be here with all of you guys, but I'm glad to be able to deliver these notes via the magic of YouTube. All right, we are going to learn today about trigonometric ratios. It's trigonometry. Trigonometry is the study between the relationship between the angles and the sides of triangles. We can use trigonometry to solve for a missing side length or a missing angle measure. The trigonometric ratios, okay, so everything that you're going to learn for the next couple of days is all going to be involved in trigonometric ratios. Trigonometric ratios is a ratio of two sides of a right triangle. Right? Again, always a right triangle. So, if we look at a given right triangle right here, and we normally refer to angles as unknown. You know that when we have letters as variables as unknown, we call them an x. When we have an angle that is an unknown, we call it theta. That theta is a Greek letter. It looks like an O with a belt. And it makes the TH sound, so that's theta is the Greek letter. So we'll say sine theta, cosine theta, tangent theta, etc. Now, if I look at my angle theta right here, I can name the three sides relative to angle theta as where they're located. We have the adjacent side. All right, and remember, adjacent means next to. So this is the side of the angle that is adjacent to angle theta. It is next to it. We have, of course, over here we have the hypotenuse, which is defined as the longest side. And then we have the opposite side. All right? And opposite in triangles is across from. So if I ask you to tell me what is the adjacent side, it's the side that touches the angle, that's next to the angle, but it's not the hypotenuse. The hypotenuse, of course, is the longest side. The opposite side is the one that does not touch it at all. So we look at this theta has a given measure, and we know that all right triangles that have this same angle measure theta, let's say it's 27 degrees. So all right triangles that have a 90-degree angle and a 27-degree angle are similar. So big or small, they all have the same ratios to sizes. So we can look at the ratio of the opposite side, so our opposite side divided by our hypotenuse, and that is called the sine ratio. Sine is spelled S-I-N-E, and it's abbreviated because mathematicians are really, really busy and can't be troubled to write all four letters, so it's abbreviated with S-I-N, and we say sine. If I do the adjacent over the hypotenuse, adjacent, remember, is next to the adjacent over the hypotenuse is the cosine ratio. And cosine is abbreviated COS. And then the opposite side over the adjacent side is the tangent ratio. All right? You have these buttons on your calculator. All right? So if I look at a standard TI calculator, right here across the middle, I've got sine, cosine, and tangent right across there. Those will calculate the ratios based on the given angle. Now, there is a handy-dandy mnemonic, and it goes with an Indian chief who was so fascinated by the study of trigonometry that he decided to name his son in such a manner as so that all the world will know how to, or at least all the English-speaking world, would know how to organize the trigonometric ratios. And that is this Indian name, Sokotoa. So the Indian was named Sokotoa. It's a mnemonic, it's an acronym, and it stands for sine is opposite over hypotenuse. Hypotenuse. All right, cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so those are all of our trig ratios. We say so, ka, toa. So, ka, toa. Sine is opposite of hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So we should always be able to, if you can remember SOHCAHTOA, you should remember how to organize your trig ratios. Now, at the bottom of this page, it says calculator reminder. So our calculator reminder is always check that you're in degree mode. All right, so there are two different ways that we'll talk about of measuring angles on in math. Degrees, which you're familiar with, which we use 90 degrees, 45 degrees, 70 degrees, etc. And then later on we'll learn about radians, which is a different measure. Now, unfortunately, radians is a little more mathematically useful, so all calculators default into radians. So in order to make sure you're in degrees, you have to press the mode button on your TI calculator. Mode is right here. And you'll see if you go down to the third one, radian is highlighted. You've always got to go over and press enter and then make sure degree is highlighted. If you're using the calculator on your iPhone, it defaults to degrees, so you don't have to change that. But if you're using a TI calculator here, or if you're using the app Calculate 84, or if you're using the TI calculator on your Chromebooks, then you have to go over and make sure it's in degrees by going to mode and then going down 3. All right? So then I'm set. Now if I go back to mode, you can see the degree is highlighted. All right, so that's all of our intro. We're in degree mode. Trig ratios are the ratio of two sides of a right triangle. We've got so, ka, toa in order to remember it. So let's work out some example problems. You'll almost always need a calculator here. So here we go. We're going to write out each trigonometric ratio as a fraction and then as a decimal rounded to the nearest hundredth. All right, so that's 2 decimal places. Remember, we have so, ka, toa. Can't write that enough times. So if I wanted to find sine of angle K, so angle K is right here. Sine is opposite over hypotenuse. So with respect to K, 12 is the opposite. So this is 12 over 13, which is equal to, if I ask my calculator, 12 over 13 is equal to 0.92. Cosine K. Now, if I'm still looking at K, cosine is adjacent over hypotenuse. So the cosine of K then is 5 over 13, which is equal to, if I ask my calculator, 0.38. And then finally, tangent of K is opposite over adjacent. So this is 12 over 5. 12 divided by 5 is 2.4. Okay, so that's sine of K. If I go to the other angle and now start looking at J. Now I'm doing sine of J. I want opposite over hypotenuse, so the opposite to J is 5 because it's across from it. So sine of J is 5 over 13, which is equal to 0.38. 0.38. Cosine of J is adjacent over hypotenuse. 12 is adjacent to J. So this is 12 over 13, which is still equal to 0.92. Now tangent of J is opposite over adjacent, so that's 5 over 12. And 5 over 12 is one we haven't done yet. That is 5 divided by 12 is 0.42. All right. Now, you will notice in this case, or you should notice, that if I crisscross these are the same. So for this triangle, sine of K is equal to cosine of J. And cosine of K is equal to sine of J. Because sine of K is opposite over hypotenuse. 12 is opposite to K, but cosine of J is adjacent over hypotenuse, and 12 is adjacent to J. So it's opposite to K, but it's adjacent to J. Those represent the same thing. Also, all sines and cosines, all sine and cosine will be between 0 and 1. All right? So all values that you get will be between 0 and 1. Because, think about it, the hypotenuse is the longest side. So when I put sine or cosine with hypotenuse as the denominator, it's got to be bigger than the numerator. And then the numerator then always has to be a positive number because we're dealing with length. So it's going to be a positive number divided by something bigger. So it'll approach but never quite get to 1, and it can approach but never quite get to 0. So it has to be a value between 0 and 1. If you get a negative value for sine or cosine, that means your calculator is in radians. You need to go check the mode. So it will always be positive. Always positive. All right? So always positive values of sine and cosine between 0 and 1. Tangent can be anything, but it's always positive. You can see the tangent here, I've got 2.4 because one side is bigger than the other. All right, and the inverse of that is 0.42. All right, now we can, given an angle, we can use the trig ratios in order to determine the value of that ratio. So I'm in degrees here, and if you ask me what is cosine of 76, well, I just type it right in my calculator, cosine 76. And that is going to be equal, it says nearest thousandth, that's 3 places, so that is equal to 0.241. That is the cosine ratio of 76 degrees. So what that means is any triangle, any right triangle that has a 76-degree angle, the adjacent side divided by the hypotenuse side will equal 0.24. All right, it always follows the same ratio. Next, I'm going to do sine of 8. Sine of 8 is 0.139. And then tangent of 82. Tangent 82 is 7.115. All right, again, tangent can be a number greater than 1. Every sine or cosine will be between 0 and 1. Now check out what happens. If I am, let me put this over here. I'm not sure which one of these will display it, but if I go back into radians, I'm going to hit radians and then clear, and I'm going to type in the same thing I did before, cosine 76. All right, it gives me a completely different answer. It gives me 0.824. If I do sine of 8, it gives me 0.989, completely different answer. And if it gives me tangent of 82, 0.3, it's completely different answers, wrong answers, because it's measuring the angles using a different unit of measure. It's like talking about the difference between feet and kilometers. Okay, you're going to come up with a different idea where you go either way. So always make sure you're in degrees so you get the right answer. Sometimes you can get a negative answer for it. They didn't show up here, but they can happen. All right, now, example 3. We want to use our calculator to find the angles. All right, so what we don't know, we're given the trig ratio. I'm told that I've got sine of some angle equals 0.7245. So we're saying, what is the angle? All right, the way to do it, if you're given the side, or if you're given the ratio, or you're given the two side lengths, then you're going to use the inverse function. Inverse trig function. All right? So this means that if I had sine A equals 0.7245, just like you undo, if you have something squared, you undo it by doing square root. If you have something square root, you undo it by doing squared. If I have the sine of something, I undo it by doing sine inverse. All right, so on our calculator, it's the second function of the sine key. And if I'm doing it on an iPhone calculator, let me see if I can show that. All right, so here's my iPhone calculator. I've got sine, cosine, and tangent down here. If I hit the second button, then it turns to sine -1, cosine -1, tangent -1. We say sine inverse, cosine inverse, tangent inverse. All right, so your iPhone can do this as well, or other substandard communication devices. So here I go. I've got sine A equals 7.7245. So the way that I write it to determine it is I'm going to say A equals sine inverse of 0.7245. So that's what I'm going to type into my calculator. I'm going to go second sine, so it gives me sine inverse of 0.7245. And that is, that is equal to 46.4 degrees. All right. So if it's cosine F, I'm going to say F is equal to cosine inverse of 0.1212. So F is equal to second cosine of 0.1212 is 83.04 degrees, or 83.0 degrees. And finally, tangent M, I'm going to say M equals tangent inverse of 0.4279. So M equals tangent inverse of 0.4279 is 23.2 degrees. All right, so if you're given the angle, to find the side, you use the trig function. If you're given the sides, to find the angle, you use the trig inverse function. All right, so now let's refer back to special right triangles and see what these looks like. We want to write sine 60 as a fraction. Well, we've got to create a 30, 60, 90 triangle. All right, so this is our 60-degree angle up here. This is our 30. We know the side lengths are 2L, L, and L squared of 3. Sine is SOHCAHTOA, so sine is opposite over hypotenuse. So I'm going to write sine of 60 equals the opposite side, which is L squared of 3, and the hypotenuse is 2L. Well, the L's cancel, so that means that sine of 60 equals the square root of 3 over 2. That is sine of 60. And what about tangent 45? Well, let's write a 45, 45, 90 triangle. So each of those angles are 45. So we know that this is L, L, and L squared of 2. But tangent of 45, tangent is opposite over adjacent. So then tangent of 45 is equal to the opposite over the adjacent. This is just L over L. So tangent of 45, L over L is equal to 1. Just like that. All right. Using what you've learned above, you've got 4 examples down here to work out. I want you to pause the video, attempt the examples first. You can go one at a time, whichever, but don't just let the video play. Try each example before the video goes, and then check your work on the video. All right, so pause it, and then work them all out, and come back, and take a pause between each one of them if you need to, or between all 4. All right, welcome back. Example 6, we're solving for side length here. We want to know what is x. I've got a 30-degree angle down here, so I'm going to label the sides. This is my opposite side. This is my hypotenuse side. So I need the trig function that involves opposite over hypotenuse. Opposite over hypotenuse is sine. Sine is opposite over hypotenuse. So I'm going to say sine of 30 is equal to x over 25. Now, sine of 30 is just a number. You're going to type that in your calculator. It's going to give you a decimal approximation. So I treat sine of 30 as just one thing. Okay, so I need to solve for x, so I multiply both sides by 25. So I'm going to get 25 sine 30 equals x. So that's what I type into my calculator, 25 sine 30, and it tells me it is x is equal to 12.5. All right. We should have known that using special right triangles. This is a 30, 60, 90. 25 is 2L, so x is just L, which is half of that, so 12.5. But that's how we can solve it using trig functions. Okay? Pause it and let's check out example 7. Okay, same thing here on example 7. I've got this angle. I'm going to label the sides. This x is adjacent. The 10 is hypotenuse. So I need one that has adjacent and hypotenuse. That's cosine. Cosine is adjacent over hypotenuse. So I'm going to say cosine of 55 equals adjacent x over hypotenuse 10. Multiply both sides by 10. I'm going to get 10 cosine 55 equals x. So x equals, here we go, 10 cosine 55, 5.74. Is my side length there, 5.74. So again, when I know the side, when I know the angle, and I'm solving for the side, I just use the trig function. For example, 8 and 9, I know the sides, and I'm going to solve for the angle. All right? So here we go. All right. So I want to find the measure of C, measure of A, and AC. All right, so let's start with A. Relative to A, if I'm looking at A, relative to A, I've got the adjacent and the opposite. Okay, which function has adjacent and opposite? That is tangent. So I'm going to say tangent of A equals opposite over adjacent, 5 over 7.5. Again, I'm trying to find A, so I'm going to use tangent inverse. So I'm going to say A is equal to tangent inverse of 5 over 7.5. So A is equal to tangent inverse of 5 divided by 7.5, which is 33.69 degrees. Okay, so if A is 33.69, that means that C has to be equal to that minus 90, or 90 minus that, so it's 56.31 degrees. Because those two have to add up. Now I want to find what is AC. Well, AC is the hypotenuse. So I could use the Pythagorean theorem to find it, but we're going to use trig ratios today. So we know that A is 33.69 degrees. So if I said sine of 33.69, that's going to be equal to opposite over hypotenuse. So this is 5 over AC. Now I need to cross multiply essentially, but I'm going to multiply both sides times AC. And then that's going to give me AC sine 33.69 equals 5. So now I divide by, remember, sine 33.69 is just a number. So I can divide by that whole thing, 33.69, sine 33.69. So that means that AC is going to be equal to 5 divided by sine of 33.69. So 9.01 is my AC. All right. And again, if I use the Pythagorean theorem, I could say 5 squared plus 7.5 squared, and then take the square root of that. It gives me pretty much the same answer, just a little bit of rounding error. All right. So there's our 3 answers. Again, pause it and try to do example 9 on your own. Welcome back. Last problem of the day. Let's crack it out. So if I look, I'm going to start with angle Y. This is my adjacent, and this is my opposite. So I can say tangent of Y equals opposite 8.6 over adjacent. So again, I know the side length, so I'm going to use the tangent inverse of 8.6 over 11. So that tells me Y is equal to tangent inverse of 8.6 divided by 11, 38.02 degrees. All right, so if that's Y, then angle Z is going to be equal to 90 minus that, which is 51.98 degrees. And I want to find YZ, so I'm using angle Y again. If I said this time, if I said cosine of Y, it's going to be, cosine is so chi-toa, so adjacent over hypotenuse. That is 11 over yz, but I know what y is, 38.02. All right, so again, we're going to multiply by yz, multiply by yz. I get yz cosine 38.02 equals 11. So I'm going to divide both sides by cosine 38.02. Cosine 38.02. So that's going to give me yz is equal to 11 divided by cosine 38.02. A little bit of rounding, but that's going to give me yz equals 13.96. There's y, and angle z. And again, let's check it using Pythagorean theorem. 11 squared plus 8.6 squared, and then take the square root of that. 13.96 again. Just a little bit of rounding error. All right, that's a lot of stuff. That is the basics of trig ratios. Again, it is a ratio of the side lengths given an angle in a right triangle. A given trig ratio of an angle will be the same regardless of the size of the triangle, because all right triangles with the same pairs of angles are similar. And if you know the angle, then you use the basic trig function to solve for the side lengths. If you know the side lengths, then you use the inverse function to solve for the angles. Thank you for